In this video, we will discuss problems and conceptual exercises of chapter 3 from the book James Walker. Now here in this question we are given that an airplane taxis on the runway with a speed of 16.5 meter per second. So let that the plane is running in this direction, the x direction. So its velocity will be, this is the velocity of the plane relative to the ground. This is 16.5 meter per second. And the direction is x, so we can write a unit vector x cap. So this will be the velocity, and the magnitude of the velocity nothing but the speed, which we are given to be 16.5 meter per second. Okay, now next it says that the flight attendant walks towards the plane with a speed of 1.22 meter per second, and we need to find the flight attendant's speed relative to the ground. So the flight attendant's velocity related to ground, this is what we need to calculate, and the magnitude of this velocity will tell you the speed. Now let me draw the vectors first. So this is our vector, the velocity of the plane relative to ground. Now we are also given that the velocity of the attendant relative to plane, this would be, now here this is a catch point here, that what would be the direction of this velocity. Now actually the person is running towards the tail of the plane, so he should be running like this. This will be the velocity of the attendant relative to ground. So the velocity of attendant relative to plane would be in this direction. So this is VAP, and this value is 1.22, and since it is along the negative x direction, so we can write minus 1.22 meter per second x cap. Now this question is pretty simple. We can easily calculate VAG from here. Simply we can write that VAG would be equals to VAP plus VPG. We can write this way, and it is equals to VAP, we have 16.5 meter per second x cap, and this is minus 1.22 meter per second x cap. So I can take a little bit here. This is x cap. We can solve it further, and we'll get this value to be VAG to be equals to 15.3 meter per second x cap. Now what would be the magnitude? Its magnitude would be its speed, which is equals to 15.3 meter per second. So this will be the answer for this question. Now in this question we are given that you are riding on a jet ski at an angle of 35 degrees upstream on a river flowing with a speed of 2.8 meter per second. So let us take that the river is flowing in the downward direction like this. This is 2.8 meter per second. So the velocity of the river relative to ground, this will be equals to 2.8 meter per second. Now it's in the negative y direction, so we can take minus y cap, right? And you are riding on a jet ski at an angle of 35 degrees upstream. So let me show the direction also by using this vector. So this is the relative velocity of u relative to the river. So we can write that relative velocity of jet ski relative to river, it's one and the same thing, and this angle is 35 degrees, right? And this is 2.8, so this would be 2.8 meter per second. More precisely, it should be minus with y cap, right? Now next it says that if your velocity relative to the ground is 9.5 meter per second at an angle of 25 degrees upstream. Okay, so let me show it with a different color. So this would be the vector which tell you the relative velocity of jet ski relative to ground, and this value we are given to be 9.5 meter per second, and 20 degree upstream means this angle is 20 degrees. You can write it here, this angle is 20 degrees. So this is the question that we are given. Now what they are asking that what is the speed of the jet ski relative to water. So what we need to calculate is the velocity of jet ski relative to the river, basically water we can take it to be river, and the magnitude of the velocity will be the speed. Okay, now by the concept that we studied in the relative motion, how we can write that the velocity of jet ski relative to ground, it will be equals to velocity of jet ski relative to river plus velocity of river relative to ground. Now from here we can rewrite that the velocity of jet ski relative to river will be equals to velocity of jet ski relative to ground minus velocity of river relative to ground. Okay, now we're going to put the values. So this is the magnitude is 9.5 for this velocity of jet ski relative to ground, and this angle is 20 degrees. So it will have two components in x and y direction. Let me show it on the figure. This will be its x component and this will be the y component. So we can write this as 9.5 cosine 20 degree x cap plus 9.5 sine 20 degree y cap. This thing we can write, then minus, now VRG, so this is basically our VRG, which is minus 2.8 y cap. Now we can subtract y component with the y component, so we can write VJR will be equals to, now this would become a 8.9 x cap plus this would be 3.2 y cap. This minus will become plus this is 2.8 y cap. So that would be equals to 8.9 x cap plus 6.0 y cap. So this is the vector VJR. Now what we have to find the speed. So basically you have to take we have to find the magnitude of this velocity vector. So this is the speed of the jet ski relative to river. This would be equals to under root 8.9, and the unit is meter per second. So meter per second and its whole square plus 6.0 meter per second and its whole square, and on solving this we'll get our answer nearly 11 meter per second. So this would be the speed of the jet ski relative to the river. This question will be the last question of this video, and it's a very interesting question, so pay attention to it. It says that two people take identical jet ski across a river traveling at the same speed relative to water. So there are two jet ski A and jet ski B, and they're traveling with the same speed relative to water. That means the speed of jet ski relative to water for A, and this is the jet ski relative to the speed of jet ski relative to water for B, and both this value are equal. This is what they are saying, but the difference is the jet ski A heads directly across the river and is carried downstream by a current before reaching the opposite shore. So this is our river, and let this distance be D. Now for jet ski A, it starts like this, and the water is flowing like this. This is the velocity of jet ski relative to water for A. Now jet ski B travels in a direction 35° upstream and arrives at the opposite shore directly across from the starting point. So what it says that for jet ski B, it starts like this, 35° upstream. So this angle is 35°. This is what they are saying. Now first I'll be drawing the velocity diagram for jet ski A. Okay, so it starts like this. This is the velocity of jet ski relative to water. This is for A, and this is the velocity of water relative to ground. Now what would be this? This will show the velocity of jet ski relative to ground. This is for A. Similarly, we can draw it for jet ski B. So it starts like this. This is the velocity of jet ski relative to water. This is for B. Sorry, this is J here. And this is the velocity of water relative to ground. And this will be our velocity of jet ski relative to ground. This is for B. Now you may see that this angle is 90°. Why it is so? Because if you read this line, it says that arrives, this is for jet ski B, so arrives at the opposite shore directly across from the starting point. So this is the opposite shore of the river, and water is flowing like this. Directly across means perpendicular to this velocity. So this should be the velocity of jet ski relative to ground. So that is why this is perpendicular here. Okay, so this is the data given in the question. Now there are two parts that we need to solve. In the A part, we need to tell that which jet ski reaches the opposite shore in the least time. Now we know that the time required for each jet ski would be equals to the distance covered, which is D here, divided by the x component of the jet ski velocity relative to ground. So this is VJG, and we have to take the x component. So this is the x component for the jet ski A, and this is the x component for jet ski B. From both the diagram we can say that this vector is greater than this vector. So we can say that the jet ski A will take less time or least amount of time. So this is the solution for the A part. Now next, in the B part, we have to confirm our result. Okay, so let's do it. Now time for A, this would be distance divided by the velocity of the jet ski relative to ground in the x direction. This is for A. We can write XA here because for A we are writing. And similarly for time taken for B would be D divided by VGJ and x component for B, right? Now we can take the ratio TA over TB. So this is D over VJG, this is XA, and this we can write, this would come in the numerator, so something like that, divided by D. So this thing and this thing will cancel. Now what is the x component for B? This is RB, the vector diagram for jet ski B. So from this diagram we can write that VJW cosine 35°, because this angle is 35, so this is also 35, cosine 35°, it should be equals to VJG B. We can write this thing. So this thing we can write as VJW cosine 35° divided by, this is the x component for VJG, this is here. Now its x component is nothing but this one, this would be its x component. So we can write VJW, this is for A and this is for B. And earlier we are given that these two values are equal. So this thing and this thing will cancel. So we can write that TA over TB will be equals to cosine 35°, and that is equals to 0.35. 0.82. From this we can say that TA will be equals to 0.82 times TB. So suppose if TB is 1 second, so TA will be 0.82 seconds. I've just taken this value, you can take any one. So just to compare the results, I've taken it to be 1 second, so TA would be 0.82 seconds. So TA is less than TB. So that means the jet ski A takes less time to cross the river.